All right, good morning. Welcome back to Pre-Calculus. We're going to talk about our final conic section today. We're going to talk about parabolas. So remembering conic section, okay, there we go. Cone looks something like this. Okay. And then we just take a slice of that. And we're going to get our cross-sectional area. It's going to look like the parabola that you've all known and loved since you took algebra 2. Okay, so y equals x squared. It's the same parabola. Okay, we're going to dress it up a little bit differently, but all the stuff that you already know about parabolas still stands. Okay, so don't forget all of that stuff that you guys already spent all that time and effort learning how to deal with. Okay, we have a slightly different method of presenting this to you. We're going to say that and I'll double check to make sure that I'm giving it to you the same way that they have it. Y squared equals 4 rho x. Okay, so y squared equals 4px. Wait, oh, there's like, why did you call the p a row? It's because it's actually a row. Okay, so this is a row. Okay, which looks like this, but it's because this used to be off of a circle. It used to be off of a cone. This used to be a radius. Okay, that's why it's a row for r. Okay, in this case, we have x equals y squared. Okay, that's different than y equals x squared. It's not a function. Okay, in this case, we're going to end up with x equals y squared. We're going to end up with a parabola that looks something like that, right? There's no prescription on rho being or p being positive. It can be negative. If it's negative, you're going to have one that's facing off in the other direction. Okay, that's fine. This will be rho will be less than 0. Okay, now what it is we have another point, another thing called the directrix here. This would actually be negative rho, and then our focus is x equals positive rho. So it is a collection of points, okay, that are equidistant from both this line and the focus. Okay, so whatever distance this is, swing it down to perpendicular, that's going to be the directrix. That's the distance to the directrix. So these always come in pairs, okay, which is why parabolas are symmetric. Okay, but not every point is going to have the same. It's going to have this pair of distances being equal, but clearly, like this pair of distances, right, is going to be different than say that pair of distances. That's fine. Okay, so it's just you're equating pairs of distances together. It's just a collection of points that have those pairs of distances that are the same. Okay, so that's what we're doing with that. So yeah, that's a parabola. Like I said, all the stuff from before still stands. The way you find the vertex in this section, and by the way, I don't have an issue giving you what the standard form of parabola is, just like they do with problems. So it's not you have to remember this, but it's usually y minus k equals 4 rho x minus h squared. HK would be the vertex. That's the center in the circle. It just so happens that theta happens to be whatever the Greek word is for horizontal, I believe starts with the theta. Whatever the Greek word for vertical is, starts with a kappa. Okay, so they use their letters to say that's what's going on, right? So that's why it's like that. The negative sign belongs to the equation, so you always have to swap the signs. So if they give you something like y equals y plus 3, right, is equal to a 4 rho x minus 1, then the center, the vertex is going to be at 1, negative 3. Okay, because it's y minus a negative 3 to get the plus. Okay, so that's what's going on there. So let's look at a problem, see what we have. The first one's not so bad, so we'll get into it. So it says in here. So the problem is listed down here. Okay, so remember that. So we have a y squared equals 48x. So pen go, wrong pen. Okay, right pen. So in this case, we have, so I just write the problem down. We have y squared So the standard form here, y squared equals 4 rho x. The example they gave us, y squared equals 48x. And it really is as simple as saying, okay, well, 4 rho equals 48. Divide both sides by 4, divide both sides by 4, rho is equal to 12. Okay, that's all they want us to do. Okay, so that's, well, for that part. Okay, so we'll go back and say that. Okay, rho is equal to 12. Let's go up here, plug that in, 12, and we'll check. Make this more agreeable. Okay, because they only give us one thing to do at a time, that's fine. Focus, okay, the focus is going to be at a distance of rho from the vertex. Okay, so the focus is rho units from the vertex. Okay. In this case, we have x equals y squared, so we have a parabola that looks like it's a left or a right opening thing, so it's going to open. In this case, it's going to open up to the right. So we would do something like this. Just like if I was going to ask you, like, how would I graph without all of this stuff on here? I said, could you graph x equals y squared for me? Say, well, that doesn't look like a function. Like, well, no, it doesn't. But when you get to Calc 2, you're going to be graphing things that normally you would have graphed in a vertical way. You're going to have to graph them in a horizontal way. That's just the way it goes. It takes a little bit of getting used to. It really does. But this is peanuts compared to like having to do it in 3 dimensions. Okay, so that's what we're going to do. So we are going to be rho units away from a vertex. Our vertex in this case is 0, 0. That one I don't think is too much of an issue, even though we have changed the way we spelled everything. Okay, so it's rho units away from our vertex being 0, 0. So vertex, obviously would have asked for that first, 0, 0. And our vertex is going to be 0, 12. Okay, so focus is 0. Actually, that is, no, I'm sorry. That's not 0, 12. It's 12, 0. So we are going away x values from it. Like I said, it takes a little getting used to. Right? And then the equation of the directrix, okay, since we are here, a directrix is going to be this position, okay, because we're going to be looking at the collection of points that are this distance and this distance away from the vertex. This is supposed to be the same, by the way, so not drawn to scale. Okay, so what we're going to say is, how do we make the equation for a vertical line like this? And that's going to be x equals negative 12. Okay, so the focus is rho units away. The directrix is negative rho units away. So we're going to say x equals negative 12. Okay. So x equals, let's see, x equals minus 12. Okay, done. And we can move on with our lives. Okay, so not too bad. Again, I wouldn't have a problem pitching you this problem exactly the same way that the homework pretty much does, and give you the standard form of this thing. Because again, when you're like, oh, I've got to work on conic section problems, like you've always had a chance. Like, if I'm going to make it more difficult like this, like you normally wouldn't change everything in terms of conic sections to do a calculus problem. You would just do it with the algebra that you already know how to do. Why are we making this harder? It's because we are. Okay, so you can see this one going to be in a slightly different way here. So I'm going to leave you with that, and we'll get started on the next ones and go with those. Okay, so have a good day, and I will see you in the next video.